Alrighty, this is block 2 from topic 7, rational numbers. This is on page 183 in your workbook, so you need to turn there now. Remember to pause the video if you need to for people to finish writing down notes. So, the first couple things we're going to get to, page 1, I'm actually going to assign this to your online lesson, so you're gonna see block 2 lesson on your Agile Minds, and page 1 you're actually gonna do yourself, and you'll need to write the answers in your workbook. So number 1 in your workbook is gonna be done online here when I'm done with my notes. And that goes for the same for page 2. This is actually going to be done online and in your workbook later. So number 1 and 2 is going to be online. So we'll get that later. So we're going to go ahead and skip to problem 3 on the next page. And we're going to continue our talk with rational numbers and what they're all about. And we remember from yesterday, rational numbers can be written as ratios of 2 integers as a fraction where the denominator cannot be 0. So all rational numbers can be written as a fraction with the denominator not 0. And we talked about yesterday how whole numbers could be written as fractions as well. All whole numbers can be written over 1. So we're going to take a look here, and they're looking at some whole numbers, and they're noticing that these are rational numbers because they're written over 1, and we just normally write the simplified version because we're lazy. We don't want to write all of this, so we write the simplified version. So all whole numbers reduce to 1. So that brings us to our first question, number 3. Why is an integer also rational numbers? And use examples to explain. That is because you can write any integer as a ratio of that integer and 1. For example, -4 can be written as a fraction over 1. 10 can be written as a fraction over 1, 3 as a fraction over 1. So an integer number is a rational number because integers can be written as fractions. Okay, continuing on. Looking at more here. Not all rational numbers are integers though. For instance, 2/5 is 0.4 or 4/10, and that's a decimal. That's not an integer or whole number, so it's just considered a rational number. Same thing with -7/8. It does not simplify to a whole number or an integer, so it's just considered a rational number. Sometimes rational numbers can be written as repeating decimals. For instance, this is a repeating decimal of 0.75 repeating, and 2/3 is a repeating decimal of 0.6. But it's considered a rational number. It's not an integer or a whole number. Its only definition that applies is a rational number. Sometimes we'll work with rational numbers in their decimal forms, and sometimes we'll work with rational numbers in their fraction forms. Just depends on what the problem's asking. Sometimes it's easier when it's a decimal, sometimes it's easier when it's written as a fraction. So going to question 4, it asks us to give an example of a rational number that is not an integer. We looked at a few of them. One example that I have here is 2/5 is a rational number but not an integer. because 2/5 is written as the decimal. 2/5 is written as the decimal of 0.4. And that's not a whole number, which means it can't be an integer. All right. Let's move right along. So rational numbers are very common in sports. Consider this sports scenario. Courtney plays softball. After 7 games, her batting performance can be expressed as a fraction. This fraction is a ratio of hits to at-bats. So hits, she hit 7. She went up to the plate 25 times. Okay, so this is her batting average. We look at this a lot with different sports. I do stats for basketball, softball. We look at this and see how well the players are performing in different aspects of the game. How can she convert the fraction to a decimal? Okay, so we're going to look at this. So this chick here, Courtney, this is her batting average. And we want to look at this in a decimal form. Right now it's in a fraction. So Courtney says, well, I know a decimal can be over 100. So she knew 25 times 4 gave her 100. So she multiplied her numerator times 4 and gave her 28. And anything over 100 to 8, this is in the hundredths place. So 0.28 is the equivalent of equivalent decimal to the fraction. So this goes to problem 5A, this work right here. So take a minute to copy that down. Okay, this was just one method of finding the decimal form of a fraction. She knew that if she changed this denominator to 100, she could quickly convert that to a decimal. If I had 14 over 100, it would be 0.14. That's just something she knew. If I didn't quickly know that, I could do some long division. So this is also going to be written for problem 5A. So find a spot to write this down of how you would find the decimal form for long division. We already found that that the decimal form was 0.28. We want to see how I get there from long division. So they took this, seeing how many times 25 can go into 7. They know it cannot go any time, so they put a 0 in the whole numbers because it can't go. Then they added some more zeros behind this, and they brought the decimal place up. So then they had to ask themselves, how many times can 25 go into 70? You're writing this long division. So what multiples of 25 is closest to 70? They found 25 times 10, 2 times, is 50. They subtracted that, brought down that extra 0. Now they have to see how many times 25 can go into 200. So they're thinking 25 into 200 is going to go 8 times. 8 times 25 is exactly 200. Nothing is left over. So the decimal form is 0.28, which is the same answer we got using the fractional form. But if I like this method better, it works out. Okay, I want you to try B and C by converting those to decimals. You can either work them long division, or if you want to convert them two fractions over 100, you can. Sometimes it's not so easy to do it over 100. For instance, 6 times, I don't know what would give me 100. I think it would be a decimal, so it'd be kind of pretty hard to change this to 100. But I know 20 can change to 100, so I might use the fractional trick here. So try B and C. Play the video when y'all are done to check your answers. Okay, checking your answers to B and C. You're going to solve these. And for 9/20ths, I end up getting 0.45. And then for 5/6, I end up getting 0.8 and 3 repeating. I probably would have done 9/20ths as a fraction. I would have gone 9/20ths. I want to get this to 100. 100 times, or 20 times what gives me 100? This 5. So multiply the numerator times 5 as well. 9 times 5 gives me 45. So that means this is 0.45 as a decimal. It's probably how I would have worked that fraction, because I know 20 can go into 100. However, for the 5/6, I don't quickly know something multiplied times 6 is going to give me 100. So I would probably do the long division way here. And it worked out, it would have turned out ugly since it was a repeating decimal, so long division would have been the easier method there. Alright, moving to problem 6 in our workbook. Okay, it says, in the previous pages you reviewed some key characteristics of fractions and decimals. Now apply what you know about fractions to the preparation for the hiking club's trip. Gina is a member of the hiking club. Miss Hernandez assigns her the job of preparing snacks for the hikers that will be healthy, inexpensive, and easy to carry. Gina finds a recipe for a trail mix. The recipe serves 6 people. Gina needs to figure out how much each ingredient she will need to make enough trail mix for all 32 members of the hiking club. Alright, so here's the trail mix recipe. Trail mix is a healthy snack. It got its name from hikers and backpackers who ate it on their journey. Did not know that. That's cool. For the recipe, we need all of those ingredients. And it serves 6. Alright, so we set up the problem. It says Gina begins by exploring the amount of raisins she will need for 32 servings. The recipe calls for half a cup for 6 servings. So we're going to play the animation to see what she needs to do. So one batch of the recipe serves 6. So we have that written there. So 2 batches will serve 12. We need to look at how the recipe changes. So for one batch, I have a half, because raisins, there was half of a cup, so I had a half a cup of raisins. For 2 batches, I need 2 sets of a half, and that equals 1 whole cup. You can see here, a half, and then 2 sets of a half equals a whole cup here. How I know how to multiply whole numbers and fractions, I go whole number times the top, 2 times 1, divided by the bottom. So 2 divided by 2 is 1. Alright, so we need to keep going because she needs 32 servings. So we need to continue on our chart. You should be filling this out with us as we go along. Okay, so she knows 3 batches is going to serve 18. So 3 times a half, she has 1/2, 1/2, another half, that's a whole cup, and then a half left over. Alright, still not enough servings. We need 32, so we need another 6 here. So 4 batches. 4 times 1 is 4, divided by 2. 4 divided by 2 is 2, so 2 whole cups of raisins. And we need 32 servings, so we keep going. So 5 batches gives me 30 servings. 6 batches gives me 36 servings. And I finally have enough raisins for the servings that I will need. So this says I need 6 sets of a half. I have 1/2, another a half, so we'll have 1, 2, 3, 4, 5, 6, and that equals 3 whole cups. This has 1, 2, 3, 4, 5. 5 sets of a half equals 2.5 cups. All right. So number 7 is actually going to be on your lesson for you to try to do, looking at the ingredients. We know we're going to be multiplying these fractions times 6. I taught you the trick. Multiply the whole number times the top divided by the bottom to see how many cups of each ingredients we're going to end up having. So that's going to be on your lesson online work. And you also have problem 8 in your workbook that you're going to work on, that I will be checking Tuesday for homework. So you're going to now get online, finish the lesson in your workbook, then you're going to finish problem 8 in your workbook. Then you can work on any of your more practice problems that have been assigned thus far. And we'll go over all of this next week. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.